Okay, welcome once more, everyone, and we'll be proceeding with our class. But as usual, we always have, more like an overview of what we've discussed from previous class, and let's hear from someone who is willing to give us an overview from last class on what we did, and yeah, we can progress from there. Anyone? Anyone willing to give us an overview of what we discussed? Okay, Edrin, you can proceed, please.
Good evening, everyone.
Good evening.
So last week we discussed that I'm giving an overview of the whole of last week, not like the last day.
No problem.
So last week we discussed how to set up our environment for Rust, for the Rust programming language. And then we went ahead to write a simple Hello World program and studied about data types like integers, how to use integers, how to change integers using the mute keyword, and how integers are grouped into unsigned and signed, and they are different. I don't remember that. Like unsigned 32, I don't know what we called it. I don't know whether it's bits 32 to 64, 18, 8, 16, 8, something like that. Yeah, basically that was it.
Thank you very much. Thank you very much. You gave a great overview. Anyone wants to add to what she has just made mention of? Okay, Divine.
Okay, good evening, everyone. Last week, talked about we had an introduction to Rust programming language. We talked about the features of Rust. I think we talked about the ownership model. There's a garbage collector, and that it has the modern syntax. And we also said ownership model is the fact that each variable has the ability to own its own value. Then we further went to talk about the different benefits of Rust. We talked about, I think, memory safety, type system, and concurrency. Then we went ahead to install Rust in our systems using, and we went out to write the first program, which was the Hello World program. And the next day, I think we talked about variables and data types. We talked about the mutable variables and the non-mutable variables. And then under data types, we talked about integers, booleans, floating points, then characters. So I think that's like a summary of what we did.
Great. Thank you so much, Divine. That was enlightening. That was really enlightening. I guess I will just take it as that. So, eventually Sylvanus is here. Are there any reasons why Sylvanus is late to class today? Okay. So today we'll be starting from talking about compound types. I think I spoke a little about what compound types is during the course of our last class, but I did not go deep into compound types. I know from last class, I spoke about the scalar types where I made mention of the different integers, the floating points, the Boolean, the character. Then I went on to talk about the signed and unsigned integers, and I went on to talk about the memory size, where I was able to break it down to bits, and Adrian made mention of that. Then I went on to talk about floating points, why you cannot update a data type with another different data type. I went on to talk about that too. So from last class, I did not talk about Boolean and char so well. So I only brushed it, but I'm going to talk about it in today's class. But majorly today's class will be focusing on the compound types, talking of tuples, talking of arrays, and then we talk majorly on referencing. Then from that, we talk of ownership and borrowing. Although we would not go so deeply into ownership and will not go so deeply into borrowing, but we'll talk about it for now. It will just be like a knowledge for us to hold down till we actually get into the main topic about ownership and borrowing. So without much ado, let's quickly go into compound types. What are compound types? Compound types are literally fixed collections, and these fixed collections could be either tuples or arrays. Now, what do we mean by tuples and arrays? Well, I'll share my screen to show what they are. But I want you to have at the back of your mind that when we are talking of compound types, you notice the types is in plural. That means we are talking about a situation whereby we can mix up different types together. So it's no longer just one type you are mixing together. So that's when you're talking about compound types. And in this case, there's a way for some you can mix, some you can't mix. So which one are the ones you can mix? Which one are the ones you cannot mix? Which one are the ones you can have together as a compound? These we are going to talk about at the course of today's class. So let me stop sharing my screen and just share my whole screen so that we can look to our code. So we would use our code as a vivid example for today's class. So tuples. So let's look at this. Now, let me increase this. Okay. So this is just all we did from last class, talking about that. Now let's talk about tuples. Now talking about tuples. Now, this is what a tuple look like. So we could name it tuple. Let's name it tuple 1. And inside of it, we could have different types. For example, we could have an integer. We could have a floating point. No, that's not a floating point. No, this is a floating point. Then we could have even a string slice. Oh, sorry. Something like this. This is what a tuple looks like. Notice that this encompasses different data types. We have an I32, we have a F64, and then we even have a string slice. So all of this is what a tuple looks like. Now, how then can we access the values in this tuple? Now, one thing I want you to understand is that each of the values of this tuple take a position starting from 0, 1, 2. You can think, for those coming from other programming background knowledge, you can think of it as index, having more like index 0, index 1, index 2. So that's how you can think of it for the tuple. So to access it, you basically are going to say the tuple dot the particular index it is. So let's try to just print out, let's say we are trying to print out all of the tuples. So we could say tuple 1 is this, tuple 2 is, we say this, then tuple 3 is this. Then from there we could say tuple 1.0, tuple 2, tuple 1.2, 1.1, I mean, then tuple 1.2. So if I cargo build this, I will run it. Are we going to have it? Can you see tuple 1 is 2, tuple 2 is 4.7.7, tuple 3 is LO. So you can access each of these tuple by saying dot the index of the tuple. Dot the index of the tuple. So let me ask a question now. Now, this question is just for you to just think out of the box. You know, our classes, we enjoy asking questions and just, pushing ourselves to the edge. What happens if I put tuple? Let me not type it out. What happens if I put tuple 1.3? Is there anybody willing to try? What happens if I put tuple 1.3? Yes, Yuvan.
I think it probably work
Why do you think it will work?
because if we consider that in the global suite we can have one, I think that one will be entirely included with the decimal until reaching the number 2. So technically we can have still 1.9 or 99 until reach 2.
Okay. Notice, okay, I think what is confusing you, let me remove this one from here. Removing this one, I mean, I have to remove it everywhere. Okay, thank you so much, Yuvan. Thank you so much. Someone's hand was up before Chiamobi. Was that Juanita? Yes, please, let's hear Juanita before Chiamobi.
Hello. For me, I think it will throw an error.
Yeah. Why would it throw an error?
If we have assigned only those indexes or the numbers that are places or positions for the tuples.
So let's hear Chiamobi. Chiamobi, do you think Yuvan is correct? Or Juanita is
Yes, it will throw an error. I think like array out of bound error. It will throw an array.
very correct. So Yuvan, the answer is that it will throw an error. Why would it throw an error? That is because this particular tuple has a size of 3, starting from the first one, the first element, the second one, and the third one. The first one, which is more like the first index, 0. The second one, tuple 1. But just to show that it will truly throw an error. So let's just add this and say tuple 4 is, and then we'll add this and we just say tuple, okay, tuple dot 4. Oh, let's even say dot 3. Can you see? We have a compiler error, not even a runtime error. A compiler error is the error that comes before you even finish writing your code. It tells you, bros, there's a mistake you are doing. So if you over on this, what mistake would you say? Argument never used. So in the tuple, you have I32 F64, and a string slice. So you don't have the third one. In this case, which will be the fourth one, basically. But if I should add something here, like probably even a boolean, what happens? We still have an error. Why are we having an error? 0, 1, 2. Okay. Wisdom, please. Why are we having an error?
You didn't in your print message you put your
Very good. Very good. So, in fact, let's remove this. I think we did not even indicate that even before showing the tuple. Yes. So notice no field 3. This is the error we are meant to get. This is the error we are meant to get. We didn't add it here earlier. So now, if we now add this true here, then definitely we would have this. So now this is a type of compound data type where you can compound different data types together to form one, and this is what a tuple is. Now in a situation whereby you are working, you might need or require to use a tuple. It could be a situation whereby you are returning some values and all you need to return is more like a tuple. So the tuple will just return probably two different variables and it will just work out fine like that. The next one we'll be going to is an array. So for this, we would be creating an array 1, 2, 3, 4, 5, 6. I think that's fine. So now this is an array. Now, an array from previous programming language you might know, some programming languages have arrays having dynamic size, but this array in Rust does not have dynamic size. Rather, we have a different data type that serves as an array with dynamic data type. Now, notice something from this array. This array basically now, let me make this clear. Notice that in front of this array, we have a square bracket, the array type, and the total amount of elements inside of the array. What does this mean, or what is this trying to say? This is trying to say that for this particular array type, it must have only one single data type in the array. So for example, if we were to add 0.8 here, we would have an error. Why are we having an error? This is because this particular array should only have a single data type. And unlike a different data type, which we'll be looking at, vec, which is vector, it has a fixed size. So that means, notice that we mentioned that we want to have 6 elements in this array. If I should add one more element in the array, what happens? The array throws an error. This is because the array expected an array size of 6, but found a size of 7. So all of these are cautions in Rust, whereby you do not use useless memory space that you really don't need. So this is the same thing as also a compound data type. But in this case, this particular compound data type has just one data type that it allows. So that's that for that. Now, in the case of this tuple, notice that I have something here in front of the tuple. I have this I32, F64, string slice and boolean. The moment I change this into probably I32, we will automatically have an error. Why? This is because Rust is a typed language, and any type you are trying to use for it must be the type you are using for it, and it will tell you the error at compile time. just like it is doing here. Are there any questions based on that? Janita, your hands are up. Do you have any question?
Sorry, I had left it unintentional.
Okay. So what are we moving on to? References. What is reference? Reference is the ability for a particular data to be borrowed, a particular data to be borrowed in different instances. Now, what do I mean by that? I'm going to give an example of this. So we say, let's say, let name equals string from, let's say, let's use my name for a change, Ayomide. Now, in this particular case, what if we said name 1 is equal to name? In this case, we have an error. Why do we have an error? That's because no name 1 exists, Tabi. Now, let's now say, let name 1 equals name. Notice that at this particular point, name and name 1 has already taken the value of name, right? But what can we do in this case if we do not want name 1 to completely take the value of name? That is where referencing comes in. So I'm going to show a proof to show that, yeah, name 1. Okay, why are we calling it name 1? Let's just name it first name. Let's just make it clear. First name, and let's call this one last name. So let's say this is equal to this. Okay, so in this case, let's print out the name. Okay, let me comment this out. So let's print out the name, and I'll say the last name is now, let's put this, and then we put last name. Now, if I print this, if I run this, you see the last name is now Ayomide. Now, what happens if I change this to first name? What happens? We have a compile error. Why? Because the value of first name has been moved into the last name. Does that make sense? The value of the first name has been moved into the last name. Now, in some situations, you might be passing data from a function, and then this data you are passing from a function, which we are still going to talk about when we are talking about function. We see how functions literally take over a data ownership, how a function basically owns a data once it has been passed to it. And so in that kind of situation, imagine this first name is a parameter coming into your function. How do you deal with a situation whereby you want to also use the first name for the last name? In that case, we use what we call referencing. Now, this is it. So you reference like this. Can you see? Now, in this particular case, you use this sign that looks like the and sign for referencing. And so when you use this sign, in this case, all this last name is doing is that it is pointing to this first name. So it is saying, I'm not the owner of first name, but I have access to pointing to first name. So it's in computer science, it's called pointers reference. So it's more like a data that is on the heap, and then there is more like a pointing reference to it. So at this particular time, this last name is not the owner of Ayomide. Rather, it's a reference to the value Ayomide. I think the Rust official documentation actually has a diagram. Let me look for the diagram for it. The Rust official documentation. That's a diagram for this. If I can't see the diagram quickly, I will just continue. I think, yeah, it's under reference and ownership. Yes, this is it. Yeah. So look at it. Now, here is a value LO. Here is a value LO. Now, this particular LO is stored inside S1, right? So the S1 for this LO is having a string length of 5. Can you see? So it has a capacity of 5. Now, to get to this LO on the heap, that's on the storage heap, it needs a reference. And so that reference is this particular symbol we are seeing here. And let me see if there's another diagram that shows pointing to that reference. Okay, there's no diagram showing pointing to the reference. So this particular diagram here actually makes use of a function. Like the function is usually taking up the ownership of any variable coming in, unless it is a borrowed variable that's referencing it. So in this case, they did not show. I thought there would be a show of just, okay, I think it's here. Wow, it's here. It's here. It's here. Okay, yeah. So good. Now, notice this is what I was looking for. So notice this LO has about 5 lengths of capacity, HELLO. And then it's pointing directly to what? To the heap. Now, what is heap? What exactly is that I keep talking about it in the memory? I keep talking about heap and memory. We'll get to that. Don't worry. But it keeps pointing it to the memory on the heap. But then, whenever you now assign the value to something else, to a new variable, at that particular point, this is what happens. The original one pointing to this particular value in memory does no longer have access to that value in the memory. Rather, the value has been moved to the new storage, to the new variable, I mean. And so the new variable is the one that will now have the pointer to it. But in this particular case, when you now use something like clone, which we are going to talk about, then at that particular point, the two can now point to owning it. That is, you are now saying you want to clone this particular variable, which is different from what we are talking about. Notice that what we are talking about is reference. We're talking about reference to the memory. Now, in this particular case, it's now talking about cloning. So that's basically it. Is there anyone with any question based on what we've just explained on the memory storage pointing variables? Anyone with any question? Okay, I'll assume the silence means everyone literally understands what we are talking about. So before moving on, does this now mean that we can only have just one borrow? No, it means that we can keep having so many borrows. Second name, let's name this one second name. In this case, second name can now borrow from first name. You can still borrow. You see, there's no error. This is because all of them are only referencing to the first one. They are not taking ownership of the value in the first one. Now, most of what we are saying right now is so abstract and is understandable. But as we keep going on, you keep ingesting it and you keep understanding. Now, even for those that are coming from a different programming background, it might be a little not clear. And that's still fine because it's rare for a language. There's not so many languages talk about ownership and reference, but that is one of the superpowers of Rust, ownership and reference. So with this, a value cannot just claim up another value, but it's possible for you to point to that value and not change that value. Now, notice we mentioned that first name can be referenced by last name. It can also be referenced by second name. But what happens if we now have another name? Let's call this one third name. Third name. At this particular time, third name is no longer referencing first name. Rather, third name wants to reference second name. What then happens? Did someone see what happens here? At this particular point, notice that we now have two of these reference at the back of the string type. So that means third name is a reference of second name, which is a reference of first name. So it's a reference of a reference. So it can keep going on for you to have multiple references. Now let's say fourth name, and this fourth name, we now reference third name. Remember that third name is already referencing second name, which is already referencing first name. In this case, now we now have a reference of a reference of a reference. Can you see? 3. Now, at the same time, what this means is that we have, before you can now get the original point. So it's more like, let's draw it. I like visualization. Give me a second. We should draw it. It's nice if we draw it. Can everyone see my screen? Can I hear someone unmute and speak, since I cannot see, I can only see my own screen. Can everyone see a white board on the screen? Unmute and speak. Okay, great. Now, this is what we are talking about. We have first name, which we said it is hello, right? Let me use the correct this thing. String from hello. Right? Now, what happens here is that this particular first name, it has the hello here inside of the memory. Now, the hello is sitting inside of the memory. What is now happening is that we now have second name. Now, the second name is referencing to the first name. So it is now saying reference to the first name. Now, the third name is also referencing to the first name. Now, notice the branch. The third name is referencing to the first name. The second name is referencing to the first name. But now the fourth name is now referencing to the second name, which is a reference to this memory for the first name. So that means it's now going to be reference of what? Of the first name. And it could continue on and on and on and on like that. So now, in this particular case, a reference of a reference of a reference, imagine we now lose this particular reference. What happens to this? Notice that this one is just trying to reference this one. It's just trying to borrow from here. It's more like it's borrowing money from this particular one. Imagine this one no longer have where he's borrowing it from. That means this one will lose its value automatically. Or imagine this one is no longer have. So if this one loses its own value, imagine this one value was passed on to another value. Imagine it was passed on to another value. That means that this one will still have its value, but this one will lose its value. That is because it is a reference of a reference. And that's exactly what we are talking about. Now, trust me, this is much complicated than it sounds. Or I don't know if everyone has been able to grasp what I just explained, but that is exactly how referencing works in Rust. So does everyone get what I'm trying to say now? Okay, I guess there are some hands up. Yes, Yuvan, please.
Yeah, I have a question. Actually, got it. See how the reference from a reference is like building a chain. But is it possible to link directly a last reference to the original one?
Yes, that's exactly what we did. Now, notice your question could come in two forms. It could be, is it possible to dereference all of these references? How do you do that? First of all, you do this. Let's now call this value. Let's just call it value. Now imagine you now say the reference fourth name. What do you have? Notice that after dereferencing, this symbol star is what you use to dereference. Now, if you add one more star, what happens? There's a problem because this is 2, right? Let me remove this and remove this. Okay, good. Why do we have an error? Oh. Okay. So let's say you do this. You have dereferenced this. Now notice that this no longer have, now notice that the fourth value, which used to have 3 references, has now reduced to 2 after doing this. Let's now say we do this. Let's value 2 equals this value. What happens? Notice that it has reduced again. Now, what happens when you do this? Sorry. What happens now? Notice that it has reduced to just 1 reference, as you can see. Now, let's value 3 equals this. This. We have a problem. Why? This is because you cannot dereference the main copy. So that means when you want to do this final dereferencing, it means that you are trying to now copy this one originally and put it inside of value 3. And in that case, it is like trying to get what is not for you. It's like saying the best example for this is, imagine we have a landlord, and now the landlord has a tenant. Now, tenant 1, the landlord has tenant 1, tenant 2, tenant 3. Now, tenant 1 went ahead to go and rent the house. He rented the house again for another tenant. He's a tenant, but he rented one of his rooms for another tenant. Now, that particular tenant now sent the other tenant that rented the room for him out. In that particular case, he paid the full money to that tenant. Is it possible to send the landlord of the house out too? The answer to that is no. So in this case, if you want to do that, all you have to do is you have to do what we call cloning. Now, cloning is a situation whereby you now completely copy. You do what we call copy of this particular variable into another variable without having to move the value of this variable. Now, in this case, notice that when we still have our first name is basically still having the original value, and still this is a copy of that first name having the original value. So this time we are no longer having like a pointer to it, rather we are now having the value 3 to have its own value, a copy of what is in first name. So does that make sense? Does that make sense? Okay, Sylvanus.
Can you please repeat that again?
Eh?
Can you please repeat what you're explaining? I didn't quite get it.
Which part did you not get? The referencing or the copy?
The copy.
Or the dereferencing?
The last part you say, if you don't want to reference, you want to jump other references and copy the last one, the first value.
Okay. Okay. Now notice that, let me comment all of these ones out. Now notice that when we said let's just name this one value again. Can't think of something. If we said let value equals first name, we will have a problem when we are trying to use first name again. That is because first name no longer have a value. A move has occurred. So what is, remember that when we were talking about variables, we were using example of a basket or a bucket to talk about variables, right? Now, in this particular case, what happened in line 40 is that particular bucket carrying the water, the variable, the name of that bucket is first name. Now, this line 40, we have another bucket. Now, on line 40, what you did is that you poured all the water, all the variable from line 39, which is this. You poured everything into this. And in that case, line 39, which is first name, no longer contains a variable. Now, we are now talking about, in some cases, we might need to reuse some variables and pass these variables inside of another variable without having to completely moving this variable. And in that case, that is exactly where we start talking about referencing. And we show that this sign, more like a and sign, is what is used for referencing. So referencing is all about borrowing from this. Borrowing from this. So in this case, you have borrowed from first name. So last name is another bucket, but last name borrowed from first name. So it didn't collect the water. Instead, they borrowed the water. So all it can do ever is to borrow. It cannot, return. It cannot own the water. It cannot own it because he is not the owner. The only place where he owns it is if this was not applied. And in that case, first name no longer owns that value. Rather, last name owns it. But just to create a reference to first name, we need this sign, this keyword, reference, to create it. Now, in some cases, you might not need a reference. You might need the exact same water without having to borrow value. Now, when I'm saying water, think of it as value, since I'm using bucket as your variable. Now, you might need that exact value And in this particular case, what you will do is what we call cloning. So once you clone, let's clone this. So once you clone, in this particular case, what you are cloning is the original value. So you are cloning the original value to have its own value. So in this particular case, value 3 is no longer having more like a pointer to the memory location of this value for variable first name. Rather, it is now having its own variable that has been cloned. Does that make sense, Silvanus?
Yeah, I'm getting there.
Yeah. So what exactly is ownership and borrowing from what we have just made mention of? This means that each variable has just one value that it owns. So each value has one owner. Let's go back to our code. This particular value, Ayomide, is a string. It has only one owner. And who is the owner? First name. That's the owner of that value. Now, last name can only borrow the value, but cannot own it. But the moment it moves, you remove this, it automatically moves the value into last name. And so last name becomes the new owner of the value Ayomide. So in this particular case, notice that value 3 can no longer clone first name because first name is now empty. It doesn't have a value because the value has been moved. Can you see? Value moved here. The value has been moved to another variable. Going back, values are freed when the owner goes out of scope. What do we mean by this? What are we talking about when it comes to scope? Now, while I was talking earlier, I mentioned that some particular things like function could take a value and own up a value. And in fact, this is why we sometimes use reference when we are calling or using a function sometimes. Don't worry, we are still going to go deep dive into this ownership and referencing as a whole. It's just to enlighten you. And when we are doing so, you create functions to show what we are talking about. So, but then, what am I trying to get to? Scope. Now, this is what a scope is. Now, let's say we have, let's use, let's think, I want to think of a variable name. I don't want to use name anymore. Let's say cars. Let's name it Lambo. Or let's just name it Toyota, I guess. So let's name it Toyota. Now notice that at this particular point, Toyota is the value of this variable, right? I think I want to put this outside. What happens if I now say let value equals car? Now let's say we now want to print out this. Notice that we have a problem. Why? Even though this is inside of a different scope, this particular value has been moved into this scope, right? So it cannot be printed, and that's why we have this compiler error. But what's the problem with us now saying that, or what's even the point of these curly braces that we created there for scopes? Now let's go down there. So I'm going to cancel this to show that, okay, we no longer have access to it. Now, at this particular point, we could say let value 1 equals, we borrow this value. We could borrow value and then it will become value 1 and then we can print it, right? Yes. But then what happens if we now say let value 3 equals value? And then let's say we in fact borrow it. What happens? We have a problem. Why do we have a problem when we can, let's even call this one value 2. Why do we have a borrowing problem when it is not like we have given? Remember that for this particular case, we gave car the value, we gave value the value of car, which is Toyota. I shouldn't use value, it's mixing up. Let's say car 1. Let's use this as car 1. Let's use this as car 2. Let's not use something that would confuse. The topic is already difficult enough. There's no need to make it more complicated. Okay, this is car 2. Let's just put this as car 2. Now, why is it that we cannot borrow car 1 from this particular point? Let's call this one car 3. Why is it that we cannot borrow car 1 from this particular point? But then, imagine if we come down here, we can still borrow car 3. We can even borrow car 4. Let me name this one car 4 so we don't have a mistake. And basically borrow car 1 here. And we won't have any compiler error. Is there anyone that can explain to me why we have this compiler error? Why can we not borrow this here? Yuvan, please.
Okay, based on the previous that we saw, the reference is always, most of the time, always attached to the previous one, not to the original. So if we at the stage of cat 3, it's supposed to be linked to cat 2 instead of cat 1.
Okay. So are you saying that if I change this one to cat 2, we won't have a problem?
I guess.
You get. Okay. Okay. Before Silvanus answers or wisdom answers, I'm going to change it to cat 2, and we're going to see whether we have problem or not. I've saved it. We still have a problem. Notice we still have a problem. So that is not the answer to the question. So Silvanus, let's hear from you. Why are we still having a compiler error here? Why are we having compiler?
My thinking is when you say let car 4 string, it borrowed from 1 instead of 2. So you should have 2 reference code, like those you said reference, there should be 2 instead of 1. When you say borrow from car 1, that reference.
That's a great try, but not still the answer. I saw Wisdom's hand up. I think Wisdom has something to say. Okay, Wisdom, please.
Thank you. I think when you're looking at it like a for loop, when you terminate it using that curly braces, anything outside of it cannot take a value from an initiated value from inside you called it scope, from inside the scope. So like where we take the values from, if it's inside there, it has to stay inside. It can't come outside because it's not dynamic. I don't know if I'm getting it. Yeah,
That's correct. That's correct. The answer is correct. It is in a scope. The moment a particular value or variable, should leave a scope, the owner of that value is lost. So thank you very much, Wisdom. That's the correct answer. It is in a scope. That's why I was talking about a scope. It is in a scope. Now, I'm going to do something else now. I'm going to change this one to a borrow. And then I'm going to change this also to a borrow. We don't have an error. Why don't we have an error in this case? Notice that the only thing I change is to change this one into a borrow, and then I change this one into a borrow from car. In this case, notice we spoke about scope. Why don't we have an error? Solomon, please.
Okay, sorry, I'm on transit. All right. The reason we don't have an error is because the car you are trying to reference is on the global scope, so it can easily reference it.
Thank you very much. Thank you very much. That is because it is in a global scope. And so it means that the original value of this car is in the global scope. So even if all these variables inside of this particular scope, inside this smaller scope, the value is not lost because the real original owner of this Toyota value is in the global scope. So if it comes down here, you can still reference to it from the global scope. But earlier, we moved the value. Can you see? By not adding that particular reference sign, we moved the value from car to car one. And in that case, the original owner of this particular value has been moved into car one. So that means that car no longer has a value. And in this case, we cannot reference a variable that has no value. Thank you so much, Solomon, for that answer. So this is it on referencing, on borrowing, and dereferencing. So does anyone have any question based on what we have discussed from today's class? I'll stop sharing my screen now. Does anyone have any question from what we have discussed from today's class? Wisdom, please.
Yes, please. Can you give me an example of tuple? Like, how is that being used, like in a real world case? Because now you said after it's finished, you can throw it away. I think that's a statement that you made for tuples.
No, I didn't say after you finish, you throw it away. It's just a tuple is like a normal compound data type. It's just a compound data type. You can think of saying an array. We gave example of an array, right? We gave an example of an array. Where is it? Yeah, this is it now. So let me comment this. So this is a tuple, right? And then I mentioned that you can use a tuple in different situations. It's based on your implementation. Now I'm going to give a very simple implementation. Now I don't want anybody to think of this implementation. Just look at it as me trying to just give an example, just for us to have an understanding of how to use this. I know I've not explained functions so well, and so you would just see what I'm trying to do. So I'm going to create a function that does two things. The function adds and let's say subtracts. So let's say this function, we name it add sub. So let's say it takes in num1, and num2. Let's say num1 is an I32, num2 is an I32. Oh, we have 2 here. Now, in this particular case, we want to return a tuple of I32 and I32. So we could say let's add equals num1 plus num2. Let sub equals num1 minus num2. And at the end of the day, we put everything inside a tuple. and then we return it. Can you see an example of a tuple? Or now, I know I've not mentioned functions. I'm sure what you will be familiar with me using the return sign. This also works. Wisdom that asks the question, can you
Yes.
see the example of use of a tuple?
Yes. Thank you.
Okay, great. So you can use a tuple, it's just a compound data type. So it's based on your implementation. It's just like saying, when should you use a float? When should you use an I-32? When should you use an array instead of a tuple? It is based on your design. It is based on the implementation you are working on. You get, so this is just a random implementation I just thought of based on your question, and I implemented a tuple for it. So we are still going to, others should not worry about that. We are still going to talk about all of that. But this is how we come to the end of our class for today. So I'll stop the recording.